520 million years ago, something extraordinary emerges from Earth's primordial oceans. Armored creatures with segmented bodies and compound eyes unlike anything that came before. They would dominate marine ecosystems for longer than dinosaurs walked the Earth. Over 300 million years of uninterrupted success. 20,000 species evolved, adapted, and thrived across every ancient sea and ocean floor. Some grew larger than house cats. Others developed eyes so sophisticated they could see without distortion at any distance. They survived mass extinctions that erased countless other species. They witnessed continents collide and climates transform. Tonight, we explore the most successful animals you've never heard of, the Trilobites. Ancient arthropods that conquered an alien world. Masters of adaptation. Champions of survival across geological epochs that dwarf human history entirely. Dawn of the Armored Ones. The Cambrian Explosion, 541 million years ago, represents one of biology's most spectacular transformations. Within a geological eye blink, complex life erupts across Earth's oceans in unprecedented diversity and abundance. Hard shells appear for the first time, creating fossil records that will endure for hundreds of millions of years. And among these pioneering creatures, one group rises to dominance with remarkable speed and efficiency. Trilobites, named for the three distinct lobes running lengthwise down their segmented bodies continuously. These aren't referring to head, thorax, and tail, but rather the central axial lobe flanked by plural lobes on either side. This tripartite body plan becomes the signature design that will define an entire class of organisms. Early trilobites measure just a few centimeters, scuttling across shallow seafloors, hunting for prey and scavenging. But they possess something revolutionary that gives them incredible advantages over competing species: a hard exoskeleton. Made of chitin reinforced with calcium carbonate, this armor protects them from predators and environmental hazards. It's jointed and segmented, allowing flexibility while maintaining protection, a design so successful it persists for eons. Within 20 million years, trilobites diversify into hundreds of species, occupying every available ecological niche. Some become predators, hunting worms and other soft-bodied invertebrates across the muddy Cambrian seafloor relentlessly. Others evolve into filter feeders, straining microscopic organisms from water, flowing through specialized appendages beneath them. Still others become scavengers, consuming dead organic matter and recycling nutrients through ancient ecosystems efficiently. This ecological diversity allows trilobites to spread across every ocean, colonizing habitat from shallows to depths. But perhaps their most remarkable innovation appears on either side of their heads: eyes. Trilobites develop one of the earliest sophisticated visual systems in the entire animal kingdom's history. These aren't simple light-detecting organs, but true compound eyes composed of numerous individual crystalline lenses. Most species position these eyes on fixed cheeks beside a raised central structure called the glabella. Each lens is made of calcite, transparent mineral arranged in precise, crystalline lattices that eliminate optical distortions. This allows trilobites to see clearly at any distance without the ghosting or blurring that plagues other visual systems. Two main eye types evolve: holochroal eyes with many lenses beneath a single cornea, and schizochroal eyes with fewer lenses individually covered. These eyes transform trilobites into efficient hunters capable of tracking prey across complex underwater landscapes. They can detect movement, judge distances, and respond to threats with reaction speeds unprecedented in ancient seas. Not all trilobites possess eyes. Some groups, like the Agnestina, are completely blind, likely living as parasites or planktonic drifters. But for most species, vision becomes a crucial advantage that helps them dominate Paleozoic oceans. Masters of adaptation. As millions of years pass, trilobites demonstrate evolutionary flexibility that ensures their continued success. Their basic body plan, cephalon, segmented thorax, and pygidium, remains consistent across thousands of evolving species. But within this framework, variation explodes in directions that showcase nature's creative problem-solving capabilities. Some species develop long spines protruding from their bodies, possibly for defense or sensory purposes. Others evolve smooth, streamlined forms perfect for burrowing through soft sediments on the ocean floor. Species adapted to different water depths develop varying eye sizes and positions optimized for available light. Deep-water trilobites often possess enormous eyes capable of gathering maximum light in near-total darkness. Shallow-water species sometimes reduce or lose eyes entirely, relying instead on chemical and tactile senses. Size varies dramatically. Some species remain smaller than a fingernail throughout their entire adult lives. Others achieve truly impressive dimensions that rival modern marine arthropods in sheer physical bulk. The largest trilobite ever discovered measures 72 centimeters long, longer than most house cats. Isotelus rex, found in Canada, represents the pinnacle of trilobite gigantism with 40-centimeter width and remarkable preservation. This massive creature likely prowled Ordovician seafloors as a formidable predator, hunting substantial prey with confidence. Even medium-sized trilobites like a casty reached 43 centimeters, dwarfing most invertebrates sharing their environments. But size isn't the only remarkable adaptation these creatures develop over their long evolutionary history. Many trilobites perfect the art of enrollment, rolling into defensive balls when threatened by predators. The thorax segments flex, bringing head and tail together while protecting vulnerable soft undersides completely. Some groups, like the Phacopina, evolve specialized interlocking structures, allowing their exoskeletons to seal perfectly tight. This defensive strategy proves so effective it becomes widespread across numerous trilobite lineages independently. When enrolled, trilobites present only hard, mineralized surfaces to would-be predators attempting to attack them. Antennae, legs, and delicate mouth parts remain safely tucked inside this armored sphere of protection. Fossil evidence shows healed injuries on many specimens, indicating they survived predatory encounters through enrollment defenses. These healed wounds tell stories of ancient attacks, narrow escapes, and the relentless pressures of survival. Trilobites must molt to grow, shedding their exoskeletons and forming larger ones during vulnerable periods regularly. The fact that injuries healed before death indicates trilobites survived these dangerous molting periods successfully. This resilience, combined with their reproductive success, allows them to thrive for over 300 million years. Recent fossil discoveries reveal even more about their lives. Preserved pairs of Olenoides, Serratus, show mating behavior. Males possessed specialized short appendages functioning as claspers, holding females during reproduction in ancient Cambrian seas. This sophisticated reproductive strategy appears remarkably early in trilobite evolution, indicating complex behaviors from the beginning. Rulers of the Paleozoic. For over 300 million years, trilobites reign as undisputed masters of marine ecosystems. They witness the first fish emerge, then watch as those fish diversify into countless forms. They're present when plants first colonize land, transforming barren continents into green ecosystems over millennia. They survive multiple mass extinctions that erase countless other species from existence without trace or legacy. During the Ordovician period, 480 million years ago, trilobite diversity reaches its peak. Thousands of species inhabit every ocean depth, from sunlit shallows to the deepest trenches entirely. Some become highly specialized hunters with inflated heads, housing large digestive chambers for processing substantial prey. Species with prominent glabellas like Phacopina likely hunted actively, pursuing and consuming large invertebrates with efficiency. Others specialize in sediment feeding, sifting through mud and sand for organic particles and microscopic organisms. This ecological specialization allows numerous species to coexist without directly competing for identical resources or niches. But even trilobites face challenges as the Paleozoic era progresses through successive geological periods. The late Devonian extinction, 375 million years ago, devastates marine ecosystems catastrophically worldwide. Ocean oxygen levels plummet. Temperatures fluctuate wildly. Many trilobite families vanish forever during this crisis. Survivors find themselves in a changed world where jawed fish have become dominant predators in seas. These fish possess sophisticated senses, powerful jaws, and swimming abilities that make them formidable competitors and threats. Trilobite diversity begins declining as predation pressure increases and ecological niches become occupied by vertebrates. The Carboniferous period sees further declines as ecosystems continue evolving in directions unfavorable to trilobites. By the Permian period, 290 million years ago, only a handful of species remain. These last trilobites represent the final chapter of a success story spanning over 200 million years. They've survived longer than any vertebrate lineage, outlasting countless other groups that rose and fell. But now, a catastrophe unlike anything in Earth's history is about to unfold with apocalyptic consequences. The Final Extinction. 252 million years ago, massive volcanic eruptions begin in what is now Siberia. These aren't ordinary volcanoes, but flood basalts covering millions of square kilometers with molten rock and ash. For hundreds of thousands of years, they pump carbon dioxide, sulfur dioxide, and toxic gases into atmosphere. Global temperatures spike. Ocean chemistry transforms. Acidification reaches levels incompatible with calcified organisms everywhere on Earth. Oxygen levels in seawater plummet as algae blooms die and decompose, consuming available oxygen. 95% of all marine species perish in what becomes known simply as the Great Dying. It's the most devastating mass extinction event in Earth's entire 4.5 billion year history of life. And trilobites, survivors of countless challenges over 300 million years, finally meet their end. No trilobite species survives this cataclysm despite all their evolutionary innovations and defensive adaptations accumulated. Their hard exoskeletons, sophisticated eyes, enrollment abilities, none of it matters against environmental collapse of this magnitude. The last trilobite dies somewhere in an oxygen-depleted ocean, ending an evolutionary story unmatched in duration. But their legacy endures in the fossil record, preserved in extraordinary detail across every continent. Paleontologists have described over 20,000 species, with new discoveries occurring every single year, even today. Each fossil tells part of a larger story about adaptation, survival, and the relentless march of evolutionary change. Trilobites show us that even the most successful organisms eventually face insurmountable challenges from changing environments. No adaptation guarantees survival forever. No evolutionary advantage protects against catastrophic planetary transformations completely and permanently. Yet for over 300 million years, trilobites thrived, diversified, and dominated in ways few animals achieve. They were the first to develop sophisticated vision, the first to perfect defensive enrollment strategies effectively. They pioneered ecological niches that countless later species would occupy after their extinction forever changed seas. Modern arthropods, insects, spiders, crustaceans, all share distant ancestry with these ancient armored pioneers of complex life. Every time you see a horseshoe crab or lobster, you're glimpsing echoes of trilobite body plans. 300 million years of survival. Longer than dinosaurs, longer than mammals' terrestrial reign. Trilobites proved that success isn't measured in size or strength, but in adaptability and resilience. They remind us that dominance is temporary, that extinction comes for everyone eventually. Yet their fossils endure, teaching us about ancient oceans and evolutionary innovation. In museum drawers and private collections worldwide, trilobites wait, silent witnesses to Earth's deep history. Proof that even the most successful empires must someday fall. But their story never dies.